That's the setup that my camera is using right now. It's I have to use this here thing right here, this here vise to hold it, and I got 3 boxes, and on my moving table here. So that's why I need to need to make this here camera mount so I can have a way of manipulating the camera better. And of course, I'm not going to be using this camera. I'm going to be using a regular camera I got from Walmart for $14. Nice small one. I have to make a mount for that coming up. I have to get the arms built and everything. But you can see why I want to use a different camera and a different camera mount. Okay. For this evening, what I'm going to do is I'm going to take these here pieces here that I just made last evening, and I'm going to get this in focus here so you can see it, and I'm going to face these off and do the drilling and the reaming so that it'll accept a 1/2 inch diameter wooden dowels. And the nice thing about this system is wooden dowels are very easy to get at the lumber yard and stuff like that there compared to using aluminum dowels where you have to order online and things. Plus, with wooden dowels, you can cut them real quick and you can make them any size you want, and I can make it any desired length I need to, each piece. Okay, so right now I'll go over the lathe now, and we'll start getting these here prepped for to receive the dowels. I used a 31/64 drill bit to get that started in there. I want to get a flat bottom hole, so instead of reaming, I'm going to use an end mill because an end mill will cut better for this short of distance. If I was going a longer distance, I can use a reamer, but a reamer is just a little bit too won't be too good for a flat bottom hole. But with a end mill, I can actually cut the bottom of the hole, and that would give me more cutting action than a reamer would give me. A 1/2 inch end mill tooth flute. and it'll actually act as a boring bar. Mark it off the depth I want to go to. Stock wasn't tight. Now it is. Acting like a boring bar. Cutting teeth are cutting the bottom of the hole. Okay. In a reamer for that, I'd be just reaming the walls of the hole only. When I get down to the bottom, I wouldn't be able to get the depth. By using the end mill like that there, I was able to use that, like I said, as a boring bar. Okay, let's see what it looks like now. Alright. And so now what we'll do is do the rest of them like this, and then we'll drill and put a screw in there to hold the receiving dowel. Okay, got 9 more of these to do now. Okay, it's time to do the drilling and the tapping for the set screws that's going to be used to hold the dowels in position on here. And that's what's coming up next. Use English threads, standard threads, but I have a bunch of these here metric screws laying around here, a bunch of them I don't use for anything anyhow, so I went ahead and used these for this, and tapped that to M5 0.8, and I'll use those as the binding screws to bind the shafts, the wooden dowels onto. I can use up a lot of those metric screws that I don't use normally. Okay. That was very nice. 9 more to do. I have a stop right here set up. I fit this here in the V groove in the moving jaw, so that registers on here. This is nice tight against here, and it registers against the back stop right here. Okay, that's the procedure. Get all these here done right through here, and I think I know where they got these screws from. I think these are from the hardware you get from the desktop computers. You get those hard drives, and you get those there different CD-ROMs and stuff like that, different kind of peripheral. That this is the screws that come from it, extra screws they give you. Okay, next up now would be to start making the clamping bars here. I got dimensions secured for that now, and that's what's coming up next. The screws that I have for this here are these screws here, and I think these came out of some drawer hardware from kitchen cabinets. So I got a bunch of those. Now these are English screws here. These are standard, around 832 I think they are. I put 832 nut on here. So what I'm doing now is I'm just getting set up here to see where that's going to fit in, and taking a few measurements, and I'm going to digress a little bit from the original here. I was going to use I think 1/4 here, but I'm going to change that to these here 1032 or yeah 832s screws, since that's the size that I have to use, and I got a bunch of these to use up. So I'll just use these instead of using my good screws. I'll just use these that are laying around. Okay, that's coming up next, and I have this here also to use for the strapping here, the clamping bars. Okay, so that's coming up next now on making the clamping bars now. Here's the brackets made. I haven't machined the divots in them yet. Just a little trial run here. I'll get rounded over this way here. Also, I'm going to, I have to make divots in here now using a 1/2 inch ball end mill on both sides here to ride in these here ball joints here. And what's coming up next? Very interesting setup. When I'm using small work pieces, I like to use my small vise, and I don't want to take my big vise off the table, so I use my small vise inside my big vise, which is common. But because of these set screws here, these screws here that are these T-nut screws, they're in front of the vise here, the fixed jaw. So when I put this vise back here, it doesn't come back tight to the fixed jaw, and I have to have that tight to the fixed jaw in order to use the vise properly. So the best way to do that would be to put a spacer block in there, which would be a 1-2-3 block. By putting that in there now, I can tighten this vise tight against there. But here's a nice setup about it. I send it back all the way back to here, like this. I put a parallel across here, and I'll show you on a front view here. Setting this vise in here as such, I can adjust this here so I can put a parallel in here like this, get this in front, put a parallel back here, like that, and I put my workpiece in here like this. Now, if I line this about like this, and tighten this down tight here, what I have then, once I get this down tight, this vise tight in here, what I have now is a nice setup here. I can, whenever I go to change my parts here, I can take my parallel in here like this, drop it in there, take my workpiece, drop it in like that, and I can slide it up tight against a 1-2-3 block here. And by sliding against this 1-2-3 block, I now have a reference stop that I can use to reference all the workpieces at the same position. And that's what makes this a nice setup here, because all of my reference can come off this back side here to do all the spot holes, drilling here, and things like that. So this works out to be a nice setup this way by putting the vise in there and using the 1-2-3 block in that position to be a reference stop. Okay, just want to show you the whole setup. Now the main vise is totally tight here. The small vise is tight in there now, but the movable jaw still moves because the base of this small vise is wider than the movable jaw. So now I can put my parallel in here like this here, drop my workpiece in, and then reference it to the back side to that stop, and then tighten this in here, and then that will be positioned where it needs to be. thickness over 375, 3/8 of an inch, 375 thousandths of an inch from the edge here. And now I need to get the center of the workpiece itself. So what I'll do is I'll take the workpiece out just a little bit so I can reference off the edge of it. The x-axis off the back fixed jaw. X-axis, the proper number, which would be 314 thousandths, because it's just a little bit less than 5/8. It's like 620.628, I think it is. 1, 2, 314. And that should get me in the center of the workpiece here now. Larger than 5/8. It's 0.628, not 625, so it's 0.628. That's why I moved it 314 thousandths. Okay, so now I'm going to move my workpiece back into position, tight against the stock, lock it down tight, and then that will be the first ball end mill I'll use, and come straight down in there and come down a certain distance to house the ball joint. Now, when I made these here brackets, I just cut them on my saw and I just filed them, so every bracket is not the same size. They're close, as close as I can get them, but they're not the same size. That's why I cannot turn this around the other direction and do the same thing, because the brackets change from one to another as far as the length of them. So what I'll do is I'll just do all the brackets at one time on one side, and then the important distance is center to center, and then I'll put each piece back in there, and then I'll move my table over to get the next hole on the next from center line of this one here. So with everything in the same position, I can put my next piece in. Tight against there. Tighten her up. I have the depth stop set properly here, for about 100 thousandths of an inch in depth. I have the z-axis locked, so I can just use the quill only now, the drill press. I'm using a 1/2 inch ball end mill. Get a little vibration, a little more pressure. And we are now down, all the way down, so just get a little bit, let it clean up. Now it's cleaned up. I can take it out and put the next piece in, and go right down the line like that. Tight in there, tight against the backstop. And continue on. Now it's time to move the table 1.25 inches to go from center to center of the on the y-axis for the next hole, or for the next divot. So I got my 2-inch indicator set up on the back side and a y-axis, and I'll be watching that now for 1.25 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 inch, 100, 200, and 50. 1.25 inches. That's 1.25 inches on the y-axis, and then I'll be able to drill down here, or I'll be able to send down my end mill now on this side here, and then we'll have both divots made on each bracket. two of them drilled or milled out right now to the end of with the bowling mills. But here's just a small example of how it's going to work. You can see how the divots are holding the balls in, and I'm just barely holding in the middle here. Clamp a little bit tighter, and that's going to get nice and tight. So that would be the system right there. Okay, so we got so far. We have the brackets bored out, the two divots there. I have it marked for the reference side. The next thing to do now will be to drill the center holes for where the screws will go into to cause them to be bound together. That's coming up next.